Hey there, algebra students. We are going to go over your homework assignment from last night. So I'm going to ask the teacher to go around and check and make sure that everybody has it complete. So go ahead and pause the video and check and make sure that everyone's got their notebooks and all their little strips are cut and put in the appropriate pockets. And we're going to go over those together today. So again, what we're working on is classifying rational and irrational numbers, and then we're breaking rational and irrational numbers down into integers, whole numbers, and natural numbers. Those are all things that qualify under the rational number category. So I'll just kind of go through my pockets, and then if we have any questions, we can look at those together. So irrational numbers, remember that these are decimals that never end. They have no repeating pattern. They're what we would call mumbo jumbo numbers. They're non-perfect squares, non-terminating, and non-repeating decimals, numbers that can't even be written that way properly. So square root of 32 over 2, irrational. 9 times pi, irrational. 2 times the square root of 18. Square root of 18 is not perfect square. Those are all what I had put for irrational. Now rational numbers, again, these are fractions and decimals that do end, have a repeating pattern. So when I went through and I looked at rational numbers, I said 0 over 8, 4 and 78 hundredths repeating, negative 1 and 65 hundredths, 9 and 1/9. Those I classified all as rational. Integers, I classified negative square root of 121 and negative 56 over 7. If we simplify the square root of 121, we get negative 11, and if we simplify this, we get negative 8. Whole number, I classified 3 plus the square root of 9. The square root of 9 is 3, so 3 plus 3 is 6. That's a whole number. And then natural numbers, 25 is a natural number, and then 64 over 4 is 12, I think is what I figured it out to be. I divided 64 by 4, and when I did that, I got 16. Sorry, not 12, 16. So that's how I classified those. So if you have any questions about them when I get back, we can discuss them. So just kind of put that off to the side. All right, so today we're going to get into some notes on the real number system, and that's where we're going to start out today. So this is kind of breaking it down a little bit more even than what you did in your homework. Homework was just sort of passing it out, and now what we're going to do is we're going to go through and make kind of a reference sheet. All these things are meant for you to use as references to help you along the way as we're learning. So we're looking at the real number system, and real numbers are classified as either irrational or rational numbers, and underneath rational numbers we have things like integers, whole numbers, and natural numbers. And numbers down here can be classified into multiple sets, multiple areas. So first we're going to start out by kind of going through and making our notes, and then we're going to look down here at the numbers in the bottom, and we're going to classify them into each category in which they belong. So real numbers, we abbreviate with the letter R. R stands for real numbers, and it means all numbers. So any number we're dealing with should be classified as a real number. And then underneath the real numbers classification, we have irrational numbers and rational numbers. So irrational numbers are recognized by putting a capital I, and these are decimals that never end. They have no repeating pattern. It says here to kind of think about them as what we would classify as mumbo jumbo numbers. So we've already talked before about pi, the symbol pi, imperfect squares. So an example would be square root of 2, and here we have negative 101. Again, that's an imperfect square, negative imperfect square. So that's irrational numbers. That's one side of the coin. The other side of the coin are rational numbers. And we talked about the fact that rational numbers are represented as ratios, something over another number. So because of that, we use Q. Q represents quotient. And some examples of these are all fractions and decimals that end, either they stop, they're terminating, or they repeat. They're a repeating pattern. So an example would be 1/3, -67/100ths. Perfect squares are another example. So the square root of 16. And then underneath rational numbers, we kind of delineate even more. So integers are the letter Z and are represented as the letter Z. And they are all the negative numbers, and then we'll just put like -2, -1, 0. We always start in the negatives and move our way back to 0, and then once we're at 0, we move to the positive numbers. So 1, 2, and so on and so forth. Whole numbers we represent with the letter W, and they are 0 and any other positive number. So 0, 1, 2, 3, and so on. Natural numbers are represented by the letter N, and they are any whole number greater than 1. So 1, 2, 3, 4, and so on and so forth. So that's just kind of the breakdown of the real number system. And so now what we're going to do is look down here at the bottom, and it says name all sets of numbers, all sets, so they can qualify in more than one area to which each number belongs. So when we look at the number 30 here, the number 30, it definitely qualifies as a real number. It is a number. It also classifies as a rational number. It's a fraction or decimal that ends and has a repeated pattern, so it qualifies. It's a rational number. It also qualifies as an integer and a whole number. And it also qualifies as a natural number, a number greater than 0. So that was number 1. So I kind of have to go down each one of the list of things and see. So now we're looking at this number, -11. Well, -11 I know is a real number. I also know that it is a rational number. And then I know that it is, in fact, an integer because it's a negative number. It's not a whole number, and it's not a natural number. All right, number 3, we have 5 and 4/7. 5 and 4/7. This is a mixed number here. So I know that it is a real number. And then looking, it's not never ending. It's not no repeating pattern. When I look at this, I have a decimal. So if I were to divide 4 into 7, I would get a repeating or a terminating decimal. So that would make it a rational number. The square root of 21, 21 is not a perfect square. It is a real number, but it's not a perfect square, so therefore this is an irrational number. Irrational number. The number 0, it's a real number, we know that. It is a rational number. It's also an integer. 0 falls in the integer category, the letter Z, and then it also falls under the whole number category. All right, we'll do one more together, and then I want you guys to go through and do the next 6 on your own, and we'll check them together. So negative square root of 9. So 9 is a perfect square of 3, and then when I add that negative, I get a negative 3. So it is a real number, it is a rational number, and it also qualifies as an integer because -3 is an integer. All right, so I want you guys to go ahead and do 7, 8, 9, 10, 11, and 12 on your own. We're going to pause the video here. Just do your best, and then when we come back, we'll go over all of them together. So go ahead and pause the video. All right, welcome back. Let's go over these 6 problems here. So 6/3, if I simplify that fraction, 6/5 thirds is really equal to 2. So this is a real number. It is also a rational number. 3 is an integer. 3 is a whole number. And 3 is a natural number. So it qualifies in all 5 categories. All right, number 8 is the symbol for pi. So I know that this is a real number, and I also know because there's no repeating pattern with the decimal that it is irrational. All right, 5 and 3/10 repeating. I know that this again is a real number, and because it is a decimal that is a repeating decimal, I also know that it is a rational number. It's not an integer, a whole number, or a natural number. All right, next, number 10, the square root of 144 over -3. So the square root of 144 is 12. So if I have 12 and I divide that by -3, I get -4 as my answer. So some of these you really have to solve all the way to figure out their classification. So I know that it's a real number. I know that it is rational, and I know because it's -4 when I solve it that it is an integer. Number 11, I have -2 and 875 thousandths. So again, I know this is a real number, and it is a terminating decimal. So it is a rational number. And then number 12, I have a square root of 17 over the square root of 17. Even though these are not perfect squares, a square root of one number over another is the same as saying 1. Anything over anytime the numerator and denominator are the same, that is equal to 1. So this is a real number. It is a rational number because this equals 1. It is a integer, a whole number, and a natural number. That one was kind of tricky, I personally think. So tonight, you guys are going to try this on your own. This is your homework assignment for tonight. So you can use this paper and any of the other notes we've taken and your foldables. And you're going to be working tonight on organizing the real numbers. So use all these tools to help you. You're going to place the letter of each value, so A through K, and you're going to put them where they belong. What's its value? What's its worth? And then 1 through 8, you're going to go through and just kind of answer the questions. So that's your homework tonight. It is due first thing in class tomorrow, so please make sure that you bring it with you. And I'll see you all soon.